Hey, today we're going to go through how you can extract cables from LIDAR and model the tension or derive the tension accurately based on the weather or the temperature of the day that you performed your LIDAR scan on. So what we're going to do is first click Edit and extract your poles from LIDAR. What this will do is it will place poles in appropriate locations. Sometimes it will get confused because you might have a lot of pole data at the top of the pole because you've got a bunch of cross arms. So what we can use is the snap tool, which is this one here. Click on the pole, click snap pole location to the correct location of where the pole is, so it runs through those pole points. Now once you've modeled the two poles correctly, we can now look at modeling the cable correctly. Modeling the cable is pretty simple. What we need to do is click the conductor tool and find the appropriate or the construction that you're going to be using. So I'm using a single phase construction here. And now that I've got that selected, I'm just going to string it between the two poles by left clicking on them. Now this will just place it at random locations on the pole, so it won't automatically fit to the LiDAR yet. What we need to do first is click on the cable and go to the Properties tab on the right, and you'll see that there is a segment called Catenary Definition. Over here, we define the temperature at which it was surveyed to, or surveyed at. So I'm going to type in, let's say 30 degrees, for example. And you'll see that the tension or the pattern of the cable is updated to reflect that. So 30 degrees Celsius at 10% tension. Now that we've defined the temperature at which it was surveyed, we're going to click the cable and click Edit, and then fit the selected conductors from LiDAR. This will move the attachment points of the cross arm to the right locations in the pole, and also automatically derives the tension from the pattern of the catenary of the cable. Now when you click on that the conductor, you'll see that there is a CBL automatically defined here, 9.8%, and a tension of 0.46 kilonewtons. So that is how you derive a tension if you have certain information such as your LiDAR and the temperature at which you survey the LiDAR.